Okay, so in this section we are going to talk about convolution. Why do I need to discuss convolution? So I need to know what is the Fourier of the product, first of all. And the second is which operation, let's say which operation between f and g gives me the product of Fourier of f with Fourier of g, i.e. if f goes to f hat and g goes to g hat, the first question is f times g goes to where? And the second question, if I want f hat times g hat on the right hand side, this comes from where? Okay. And why is that? Let's say I have a signal f, and then I got f hat. Okay. So this is my f hat. Okay, let's say for example f is sigma, okay, which is 1 of absolute value of x, sigma 1 is smaller than 1 and 0 otherwise. Then I got the following. Okay, and this is the sinc function, remember, from the Fourier table. I mean, this is what we call, so this is square root sine omega over omega square root of 2 over pi. This is f hat. Well, this is a signal with a lot of oscillation. What if I want only a part of the signal? Okay, I only want a part of the signal, which means I want only, let's say, the following part. Okay, let's say I'm only interested in the following part. So this will be f hat times the function that is 1 on this interval. Let's say this is on this interval, this is the interval minus a, and it is 0 elsewhere. So f hat, I want only f hat times sigma a. Okay. And then I will receive only this part of the signal without all these high frequencies oscillation. Then this is like f hat times a function which is sigma a. But remember, sigma a, what is the Fourier inverse of sigma a? Fourier inverse of sigma a, let's say, I know that sigma a, if you apply hat, you get square root of 2 over pi times sine a omega over omega. But now apply Fourier again, you get sigma a at minus x, which is the same as sigma a at x. So you can say that sigma a is the Fourier transform of the function. So let's say this is the Fourier transform. So f inverse of sigma a is equal to square root of 2 over pi sine a omega over omega. Sine a x, sorry, over x. Okay. So let's call this function g of x. So if I only want f hat times g hat, what does it mean I only want f hat times g hat? I took here f to be, for example, sigma 1 of x, but really f can be anything. And then I got my signal here, which is f hat, which is with having oscillation. Only one part of my signal, let's say only this part. This means it's f hat times the function 1 on this interval and 0 elsewhere. So this is f hat times sigma a. But sigma a by itself is the Fourier transform of the following function. So if I want to receive only this part of my signal, the question is, what should I send in physical space? Definitely, I should not send f, because f will give me the high amplitude and the low amplitude that have high oscillation. So I should send something related to f, but what is this sigma? And this is the motivation of convolution with Fourier transform. So definition, given fg in L1 of R, we define the convolution f convolves with g at x is equal integral over R f of x minus y g of y dy. So this is an integral dy, so I will get something that depends on x. Now this is a function of x. My y goes from minus infinity to positive infinity. So properties, first I have symmetry, i.e. f convolve, well, I have many stars now, f convolve with g at x equal g convolves with f at x, which means I got integral over R of f of x minus y g of y dy equal integral over R of f of y g of x minus y dy. Okay. So the proof is f convolve with g at x is equal integral over R f of x minus y g of y dy. And now I will put minus infinity positive infinity because I will need this. Let z be equal x minus y. Here I'm integrating with respect to y, so dz equal minus dy. So f convolve with g at x equal integral, when y goes to minus infinity, so z goes to positive infinity. And when y goes to positive infinity, x minus y goes to minus infinity. F of x minus y is f of z. G of y is g of y is x minus z. X minus z. And now dy is minus dz. Okay, so minus 1 times dz. But I have integral from positive infinity to minus infinity. So this is from minus infinity to positive infinity with a minus, but I have a minus 1 here that will cancel. So f of z, g of x minus z dz. And this is nothing but g convolved with f. Okay. Second property, distributivity. Mean f convolves with g plus h equal f convolves with g plus f convolves with h. And the proof here is really straightforward. So f convolves with g plus h is equal integral over R of f of y g of x minus y plus h of x minus y dy, assuming all functions are L1. So this is integral R f of y g x minus y dy plus integral over R f of y h of x minus y dy. And this is f convolved with g plus f convolved with h. Now, associativity is f convolves with g convolves with h equal f convolves with g convolves with h. Okay. Now the proof of this is pretty. So f convolves with g convolves with h at x. This is integral over R of f of y times g convolves with h at x minus y dy. Now I will write this as integral using symmetry. I will write this as f of x minus y g convolves with h at y dy. And now this is equal integral over R f of x minus y times Now g convolved with h is integral over r g of x minus y, x minus x, g of y minus z, h of z, dz, and this is dy. So this will be equal to integral over r f of x minus y, g of y minus z, h of z, dz, dy. Okay. Now I will flip the integral, so I will use Fubini's theorem. This is integral over r, f of x minus y, g of y minus z, h of z, dy, dz. Okay. And now I want dy dz. So this is integral over r. Now this does not depend on y. So this is h of z times integral over r f of x minus y, g of y minus z, d, y, and everything here dz. Okay. Now let tau be equal to x minus y. So d tau is equal minus dy. So this will be equal integral over r h of z times integral over r. Well, I have plus infinity to minus infinity, plus infinity to minus infinity. F of x minus y is f of tau. G of y minus z, I should replace y. So it's giving me y equal x minus tau. Y is equal x minus tau. So this is x minus z minus tau, d tau, well, minus d tau, and all this dz. So maybe this is equal integral over r h of z, integral from positive infinity to minus infinity, f of tau, g of x minus z minus tau, so this is a z and this is a tau, times minus d tau, and all this is dz. So this is plus infinity to minus infinity, so I have to flip the integral. H of z, integral over r, I will write it, f of tau, g of x minus z minus tau, d tau, and all this dz. But remember from the convolution, what is f convolved with g? F convolved with g at x, f of z, g of x minus z. So if I replace x by 1, this means this x will be 1. If I replace x by 5, this should be 5. If x by minus square root of pi, just x should be minus square root of pi. So if this x is x minus z here, and I have minus tau, so this is nothing but, so it's integral over r, h of z times f convolved with g, but evaluated at x minus z dz. And by definition, this is h convolved with f convolved with g. And by distributivity, this is f by symmetry. This is f convolved with g convolved with h. Okay, this is proved. For first property, f convolved with 0 is equal to 0. Well, this is proof, this is trivial. F convolved with 0, well, is integral from minus infinity to plus infinity. F of x minus y times g of y, which is 0 dy, and this is equal to 0. Okay, nothing to This is trivial. Now, f convolves 1 does not make sense. Why? Because the function 1 is not an L1 function. Because integral from minus infinity to positive infinity of 1 is equal to infinity. So you cannot you only convolve L1 functions. Okay. Now a theorem. Fg belongs to L1. So h of x equal f convolve g at x. Then h hat of omega equal square root of 2 pi f hat times g hat of omega. And this is the convolution property. So f convolve g goes to 1 to square root of 2 pi f hat times g hat. Which means in this motivation, it was here, if I want to get f hat times g hat, I should have started with 1 over radical 2 pi f times g. Okay. And what was f in this case? My f was this 1 over radical 2 pi. My f was sigma 1, and my g was square root of 2 over pi sine ax over x, and then I will get the signal I need. Okay, now the proof. Well, f convolve g hat at omega is equal 1 over square root of 2 pi by definition, integral from over r of f convolve g at x e to the minus I omega x dx. And this is equal to 1 over square root of 2 pi integral from minus infinity to positive infinity. Now f convolved with g by itself is integral from minus infinity to positive infinity f of y g of x minus y dy times e to the minus I omega x dx. And now this is equal to 1 over square root of 2 pi integral from minus infinity to positive infinity integral from minus infinity to positive infinity. I'm using Fubini here. F of y g of x minus y e to the minus I omega x dy dx. And by Fubini, this is equal to 1 over square root of 2 pi. I will switch the order of the integral, minus infinity to positive infinity, minus infinity to positive infinity, of f of y, g of x minus y, e to the minus I omega x dx dy. Now this thing here is independent of y. So this is 1 over square root of 2 pi, independent of x. Integral from minus infinity to positive infinity, f of y times integral from minus infinity to positive infinity, g of x minus y e to the minus I omega x dx dy. But this is nothing but 1 over square root of 2 pi integral from minus infinity to positive infinity. So define g sub y to be g of x minus y. This will be f of y g sub y hat of omega. But now this is 1 over square root of 2 pi was here, so okay. And if you didn't like it, which you were right, because so maybe let's do it one step before that. Okay. So this is equal 1 over square root of 2 pi integral from minus infinity to plus infinity f of y, and here this is integral from minus infinity to plus infinity g sub y at x e to the minus I omega x dx dy. But this is the Fourier transform, but I need 1 over square root of 2 pi, and so I should multiply by square root of 2 pi. So the square root of 2 pi, square root of 2 pi cancel out, so it's minus infinity plus infinity f of y g sub y hat of omega. dy. But what is the Fourier transform of the shift property? So this is equal minus infinity to positive infinity f of y times f of y times g hat of omega e to the minus I omega y. Your tau here is y dy. Now this is independent of y, so this is g hat of omega, I can put outside. Integral from minus infinity to positive infinity f of y e to the minus I omega y dy. But now again, this looks like a Fourier transform, but I need 1 over radical 2 pi, so times radical 2 pi. And this is equal square root of 2 pi g hat of omega f hat of omega, or square root of 2 pi f hat of omega g hat of omega. And that's it. Okay. So convolving in the physical space is like multiplying in the frequency space. So multiplying in the physical space by symmetry should look like convolving in the frequency space, and this is the next theorem or corollary, and now I will prove it by symmetry. So if h of x equal f of x times g of x, then h hat of omega equal 1 over square root of 2 pi of f hat convolving with g hat at omega. So multiplying in physical space is convolving in the frequency space. Proof, I will use symmetry. So f convolve with g at x. If you do convolution, you get square root of 2 pi f hat of omega g hat at omega. Applying Fourier again by symmetry, so this is symmetry, should get the function f convolve with g minus x. This is the function. Okay, so if I start with f hat convolve with g hat at x, and I apply Fourier transform, I get square root of 2 pi f hat hat omega g hat hat omega. And if I apply Fourier again, I get f hat convolve with g hat at minus x. So as a conclusion, now this is nothing but square root of 2 pi f of minus omega g of minus omega. So if I start with square root of 2 pi f of x, square root of 2 pi f of minus x g of minus x, and if I apply Fourier transform, I get f hat convolve with g hat at minus omega in the frequency space. So if this was my physical space, this is my frequency space. Okay? So f of minus x g of minus x hat is 1 over square root of 2 pi f hat convolve with g hat minus omega. Now let h of x equal f of x times g, well, f of minus x times g of minus x. Then f of x g of x is equal to h of minus x. Now by the dilation property, dilation c equal minus 1, f of f times g hat at omega equal h at minus x hat, which is 1 over absolute value of minus 1 h hat of omega over minus 1, which is equal h hat of minus omega, which is equal 1 over square root of 2 pi f hat convolve with g hat at omega. Okay, and that's the proof. Now I will do one application to partial differential equation and convolution. Okay, what happened? Sorry. So application. Solve the heat initial value problem ut equal uxx u0x equal phi of x, t positive x in R. And this is your midterm, yes? So let's solve it using Fourier transform. So this is u is a function of tx. Let u hat at t omega be the Fourier transform of u tx with respect to x, i.e. u hat of t omega equal 1 over square root of 2 pi and t from minus infinity to plus infinity utx e to the minus I omega x dx. Okay, so I'm only applying Fourier transform with respect to the variable x. Now I have ut equal uxx. This applying Fourier transform imply u sub t hat equal uxx hat. Okay. Now by differentiation property, remember I'm applying Fourier transform with respect to x. uxx hat is equal I omega square u hat, yes, and this is equal minus omega square u hat at t omega. But what is u sub t hat? What is the Fourier transform of u sub t? This does not depend, this should not depend on, the derivative is with respect to t, but the Fourier transform with respect to x. Okay, so this is something different. But now since u hat at t omega equal 1 over square root of 2 pi and t from minus infinity to plus infinity utx e to the minus I omega x dx, then by Leibniz rule u sub hat t of t omega is equal, notice that this is a derivative with respect to x, so I interchange differentiation integration, you get 1 over square root of 2 pi and t from minus infinity to plus infinity of the derivative of the integrand with respect to t, which is u sub t at tx. Here I don't have t, so it's like a constant, e to the minus I omega x dx. But this is nothing but the Fourier transform of this function. So this is u sub t hat at t omega, or the Fourier transform u sub t, or you can say Fourier of u sub t. This is what? This is d dt, or partial over partial t of u hat at t omega. Okay. So what I really proved? I proved that So I proved that u sub hat, u sub t hat equal u sub hat sub t. So what happened to the ODE? So this is u sub t. So u sub t equal uxx imply u sub t all hat equal u sub xx all hat, and this imply u hat sub t equal minus omega square u sub hat. Okay. Now u0x equal f of x. This imply applying u hat with respect to x. So u hat at 0 omega with phi of x will be phi hat of omega. Then u hat solve the following boundary value or initial value problem. U sub hat sub t equal minus omega square u sub hat, and u sub hat of 0 omega equal phi hat of omega. This is t positive omega in R. But now I know how to solve the following So okay, you had solved the following initial value problem. Sorry, I mean the iPad is. So you had sub t equal minus omega square u sub hat, and u hat of 0 omega equal phi hat of omega. This is for t positive omega in R. And remember, u sub hat is a function of u sub hat t omega. But now, how do I solve u hat sub t equal minus omega square u hat? This is an ODE-like. I don't have differentiation with respect to omega, i.e., let y of t be equal u hat of t omega, then you get y prime equal minus omega square y. But now omega is like a constant, so this is like y of t you get here is a e to the minus omega square y of t e to the minus omega square t. And this implies u hat of t omega, a is a constant independent of t. So u hat of t omega is equal a of omega e to the minus omega square t, but u hat of t of 0 omega equal a of omega, and we said equal phi of omega. So the solution is u hat at t omega equal phi hat of omega e to the omega square t. So this is the Fourier, the product of function of omega. And now I want to calculate u of tx. So this is the Fourier inverse of phi hat of omega e to the omega square t. Okay. Now I know that phi of x goes to phi hat of omega, but I have here e to the minus omega square t. But e to the minus omega square t is the Fourier transform of which function? Now you go to your table or to your homework. So from the table, I'm sorry about this interruption at the end, but the iPad seems to crash. Okay, I have that e to the minus ax squared, if you apply Fourier transform, goes to 1 over square root of 2a e to the minus omega squared over 4a. Okay, this you should know it. You should know how to prove it. It's in your homework. It's in your book. Okay, and this is on your table. So here I want to get the Fourier inverse of the following function. So here you have t equal 1 over 4a. So this implies that if this imply here a is 1 over 4t. So now replace 1 over square root of 2 times 1 over 4t times e to the minus omega square t comes from e to the minus ax squared. X squared 1 over square root of 2 times 1 over 4t e to the minus omega square t comes from e to the minus ax squared e to the minus x squared over 4t. And now this implies that square root of 2t e to the minus omega squared t comes from e to the minus x squared over 4t. And this implies minus e to the minus omega squared t is 1 over square root of 2t e to the minus x squared over 4t. Then u hat of t omega, which will prove is phi hat of omega times e to the minus omega squared t, is the Fourier of phi times the Fourier of 1 over square root of 2t e to the minus x squared over 4t. Okay. And I know that f convolves with g goes to square root of 2 pi. So I know that f convolve with G, with a Fourier, goes to 1 over square root of 2 pi f hat G hat, correct? So phi convolves with 1 over square root of 2t e to the minus x squared over 4t is the Fourier of 1 over square, the Fourier of this 1 over square root of 2 pi phi hat times the Fourier of this one, which is e to the minus omega squared t. So I'm here, okay? And then, I mean, this is the whole point of doing Fourier transform in this course, okay? To solve such kind of differential equation. So you get u of tx, okay? I mean, you have u hat of t omega is this. So u of tx, which is the Fourier inverse of u hat of t omega, is equal to square root of 2 pi is equal to square root of 2 pi times phi convolved with 1 over square root of 2t e to the minus x squared over 4t. And this is equal, remember this is convolution with respect to x, okay? Not with respect to t. So this is u of tx, so the t is like a constant, of 1 over square root of 2 square root of 2, this is 2 square root of pi t, so this is like square root of 4 pi t phi convolved with e to the minus x squared over 4t, and this is 1 over square root of 4 pi t integral from minus infinity to plus infinity phi of y e to the minus x minus y squared over 4t dy, and this is exactly what you got in the homework, in the exam, sorry. Okay, so I'll stop here, and then I will do some graphical computation of convolution, and then I will, okay, and then that will be end of the convolution section. I hope this interruption with the video will stop.